Well, for a very good evening, ladies and gentlemen. Welcome to yet another episode of Perceptive Learning Zone. And today we continue our discussion about the sector of electrical engineering. So I want to start off this session and set a good tone for it by answering some very commonly, frequently asked questions regarding this domain, right? So, and also this way we can just quickly recap what we studied, what we talked about in the previous episode. So, question number one: what are the career prospects for electrical engineers in Pakistan in a nutshell? So, electrical engineers in Pakistan, they have diverse opportunities. You could work in power generation, you could gravitate towards telecommunication. Likewise, you could make a case for your employment in the manufacturing sector, and also you could maybe strike occupation in the renewable energy department as well, right? Other question, are there specialized educational programs for electrical engineering in Pakistan? Yes. Various universities do offer specialized programs. They do provide comprehensive education in this field. And for that, my dear students, there are just too many examples for me to give. So I would say just make sure you visit the course website and you'll find all the details of the specializations over there. However, if you're still in doubt, you can just visit the university or call up their admission office, get some expert on the other end of the line to give you much more in-depth info about your relevant query, right? How important is electrical infrastructure development for the country's progress? Next question. So, electrical infrastructure development is crucial because it ensures reliable power supply. And this, in the process, facilitates economic growth as well as technological development, right? Is there scope for research and innovation in the field of electrical engineering? Yes. I would say research and innovation, they are pivotal for advancing engineering, for addressing its challenges, for embracing new technologies. Yes, in Pakistan, there's very limited innovation and research, especially in electrical engineering. But then again, hopefully, that's where you guys come in, right? The Japanese school of thought: if one can do it, so can I. If no one can do it, then I must do it, right? So the onus is on you, my dear students. What are the prospects for electrical engineers in the renewable sector? We already talked about it, that the prospects are good. They can contribute to sustainable energy development, right? A question that I typically try to bypass, but I'll just talk about it quickly as well. How much an electrical engineer earns in Pakistan? So it's typically between 50,000 to 1,50,000 a month. Once again, it varies based on your experience, based on your specialization, but it gets better with time, right? Are electrical engineers in high demand? Yes, you can say they're in high demand. And that's mainly due to infrastructure projects, technological advancements, as well as the evolving energy sector. Now, a very brilliant student of mine asked me a few questions on this domain, where I told her initially that I was going to be doing a series on this subject matter. So, and these are very important questions, I would say, and I would like to be giving a little bit more exposition to the following 3 or 4 questions. So, the question: should we pursue specialization in the field of electrical engineering, or should we opt for a more general approach? Yes. So this is a crucial choice that you have to make, first of all. Specialization, it offers significant advantages. This includes, for instance, higher salaries. You could say approximately around about 20 to 30% more as opposed to generalists, right? Also, specialization has other advantage, that is, there's a deeper market demand. It gives you deeper knowledge in areas like renewable energy or embedded systems, for example. So also, I would say that specialized engineers, fellows, they are often sought after for complex projects as well as leadership roles, and therefore this provides you, with excellent growth opportunities. At the same time, right, behind every cloud there's a silver lining. So if you look at the other side of the coin, specialization can limit flexibility, especially if your chosen field becomes less relevant due to changes in the market, for instance. On the other hand, a general approach, it offers versatility. It offers you more adaptability. It enables professionals to work across various subfields as well as easily transition between industries. Now, while it provides a broad foundation, specialization may lack the depth that is needed for research intensive or some niche roles. So, what would my stance be for the uninitiated, for the new student who is fresh in this domain? I would say a recommended strategy is to begin with a general approach and then try to perceive pivoting to a specialization that is based on evolving industry trends or that is based on your own personal interests, my dear students. For instance, in Pakistan, if you talk about it, these specializations in power systems as well as renewable energy, they are emerging. While electronics and embedded systems, they have significant global demand. So I hope this answers the question. Another question that we get once again is that you have two streams, the power stream and the electronic stream. I believe I gave some emphasis on it in the last video. So the students say that choosing between these two streams is a tough decision. How should we go about it? Once again, a very good question. Now, the choice, ladies and gentlemen, between power and electronics engineering, now it depends on career aspirations. It depends on industry demand. So power engineering, it focuses on, like I said before, power generation, transmission, as well as distribution. It addresses Pakistan's critical energy challenges. Opportunities do exist in utility companies like WAPDA, K Electric, with demand for expertise in high voltage systems as well as renewable energy integration. Now, the growth prospects in power engineering, they are fairly promising as Pakistan is aiming to invest in solar and hydropower projects to reduce its energy deficit. Conversely, electronic engineering, it dominates industries such as consumer electronics, telecommunications, and automation. So, with the global IoT market projected to grow 25% annually, I would say that expertise in embedded systems as well as VLSI design, it offers pretty much lucrative opportunities, you can say. Now, electronics engineering, my dear students, it provides broader international prospects, yeah, especially in automation as well as semiconductor manufacturing. So, for those of you who are focused on solving Pakistan's energy crisis, power engineering is quite ideal, whereas the electronics engineering is a far better domain suited for the global tech-driven industries. Then next up, the question arises, is studying electrical engineering in Pakistan worth it, especially considering the limited research opportunities? Now, the next video after this, which will happen to be our last video on electrical engineering, it is going to go in more depth in terms of analyzing the pros and cons and providing a verdict as to whether or not it is worth it. However, I would just like to briefly touch it over here that studying electrical engineering in Pakistan has its advantages and disadvantages at the same time, right? You've heard that saying in life is mulk mein itni bijli nahi hai jitne electrical engineers are, right? So local education, my dear students, that is cost efficient. It offers proximity to industries like WAPDA and WCA. So it facilitates internships. It gives you a practical exposure. Furthermore, the curricula, they often address Pakistan's specific energy as well as electronics challenges. However, the problem is that the research and development remains starkly limited as Pakistan allocates only, I believe, if I'm not wrong, 0.25% of its GDP to research and development, and therefore this results in outdated infrastructure in many institutions. So to counter this, students can leverage, what can they do? Well, they can leverage international collaborations through universities like NAST and GKI, or pursue, specialized certifications online via platforms like Coursera and EDX. So studying electrical engineering can be worthwhile. And I'm not just saying it to make you feel better, but this is the truth that studying electrical engineering in Pakistan can be worthwhile if it is complemented by internships, certifications, and attractive networking. For those who are seeking more research-intensive careers in this field, then planning for a master's degree abroad in regions like Europe or North America is recommended. So finally, there's another question, once again from my same brilliant student, that should we still choose electrical engineering considering the potential workplace hazards? Now, this gives me some safety vibes, but I'll just go over it quickly again. That electrical engineering involves workplace hazards such as electric shocks. Then you got exposure to EMF, which sort of stands for electromagnetic fields, as well as risks from heavy machinery during installation or maintenance. Now, these risks, while they're real, they can be mitigated by adhering to IEEE safety standards, Institute of Electronics and Electrical Engineering. These risks can also be substantially neutralized or minimized by wearing personal protective equipment, by undergoing continuous training, which comes under the domain of administrative controls. So, moreover, advancements in automation, I would say that they have reduced, ladies and gentlemen, they have reduced direct exposure to hazardous tasks by enabling remote operations. So, despite these risks, this field is offering significant rewards. It is and those rewards, they include high demand, they include job satisfaction from solving critical problems in energy, in technology, in automation. So we can say firmly, with reasonable confidence, that electrical engineering remains indispensable, with global job growth projected at 7% over the next decade. Therefore, while the risks do exist, they are manageable. And my dear students, the profession's benefits, they far outweigh its challenges for those who are passionate about innovation in energy as well as technology. Now, I would like to quickly talk about some latest trends in electrical engineering, which are hot topics of discussion nowadays with loads of scope for those of you who are just getting their breakthroughs in this sector. So, obviously, first of all, I would like to talk quickly about renewable energy technologies. Now, renewable energy technologies, ladies and gentlemen, they are at the forefront of the latest trends in electrical engineering. Engineers are actively developing and refining technologies that harness power from the sun, wind, and water. Solar panels and wind turbines are becoming more efficient, while new methods of harnessing hydroelectric power, they are being explored. In the realm of solar power, engineers are working on photovoltaic cells that can convert more sunlight into electricity. So they're also developing solar thermal systems that use the sun's heat to generate power. Wind energy is also seeing significant advancements, with engineers designing more, what shall I say, efficient, more durable wind turbines. Also, furthermore, the field of hydroelectric power is also evolving. Engineers now are not only improving the traditional dam-based systems, but they're also exploring innovative methods like tidal power and wave energy. So these renewable energy technologies are not only environmentally friendly, but they also have the potential to reshape the global energy landscape, which is very good in case you are an electrical engineer or planning to be one. Now, another area of popularity as far as electrical engineering is concerned, my dear students, that is smart grids. They are rapidly, drastically transforming the electrical engineering landscape. Now, what are smart grids? Let's try to understand them. Now, smart grids, ladies and gentlemen, they are electricity networks that use digital technology to monitor as well as manage the transport of electricity from all generations sources to meet the varying electricity demands of end users. Smart grids, they offer you, my dear students, they offer you numerous advantages over traditional power grids. I'm not going to go too much in the technicals, don't want it to be a boring sermon. It already is. So they can integrate renewable energy sources. Let's just talk about it superficially. Smart grids, they integrate renewable energy sources. They improve the reliability of electricity supply. They provide you real-time information about power usage. Now, engineers are working on various aspects of smart grids, from developing advanced metering infrastructure to designing systems for demand response, for load management. So also additionally, I would like to remark at this stage that the integration of renewable energy sources into smart grids, this is a key area of focus. Engineers are developing technologies and systems to fundamentally manage the intermittent start-stop nature of renewable energy and sort of ensure a stable power supply. They are also working on energy storage solutions such as advanced batteries, you got flywheels, the purpose of which is to store the excess power generated by renewable energy sources and to basically use it when it is needed. Now, another popular trend nowadays in electrical engineering we see is the electric vehicles. Yes. So the rise of electric vehicles, which are abbreviated as EVs, this is another trend that is driving innovation in electrical engineering. Now, engineers are playing a crucial role in the design and development of EVs. They're working on everything from battery technology to charging infrastructure. So battery technology, folks, this is a key area of focus in EV development. Engineers are working on improving the energy density. They're working on improving the charging speed of the batteries while also making them safer and more durable. They're also exploring new types of batteries, such as solid state batteries that could offer significant advantages over current lithium ion batteries. Now, in addition to battery technology, engineers are also working on the charging infrastructure for EVs. They are developing fast charging solutions. And obviously, those of you who have been abroad, you clearly know about this. They are developing fast charging stations that can charge electric vehicles in minutes rather than hours. They're also trying to develop wireless charging technologies that could charge electric vehicles without the need for cables. They're also working on integrating EV charging into the power grid in a way that balances the demand for electricity with the supply. Another popular area in the domain of electrical engineering is, that is AI. Obviously, artificial intelligence is making its mark in electrical engineering, especially in the power systems. Those of you who are, planning on gravitating towards power engineering, make sure you listen carefully. AI can analyze vast amounts of data to predict the power demand, to identify faults in the power grid, to optimize energy use. So engineers are now using AI to develop smart meters that can provide detailed information about power usage. They can help customers reduce their energy consumption. They're also using AI to monitor the power grid and quickly identify any faults or issues, which can help prevent power outages and improve the reliability of the power supply. Moreover, artificial intelligence, my dear students, it is playing a role in the integration of renewable energy sources into the power grid. It can predict the output of renewable energy sources based on weather data, which can help manage the intermittent nature of renewable energy. AI can also optimize the storage as well as use of renewable energy, helping to ensure a stable power supply. Another popular trend in the field of electrical engineering is IoT, the Internet of Things. Yes. Now, the Internet of Things, my dear students, it involves connecting devices and systems via the internet, allowing them to communicate as well as share data. In the field of electrical engineering, IoT is being used in various ways. For example, it is being used in smart grids to connect various components of the power grid from generation sources to end users. Now, this allows you for real-time monitoring as well as management of the power grid, hence improving its efficiency as well as reliability. IoT is also being used in the development of smart homes, in the development of buildings. Engineers are designing systems that can control the lighting, the heating, and other electrical systems based on occupancy and usage patterns, right? So this helps to reduce, I would say, this would have to reduce energy consumption. Also, IoT devices are being developed that can monitor and control the use of electricity in homes and buildings, providing consumers with more control over their energy usage. Once again, they're saying of Nikola Tesla that electricity is not merely about illuminating your homes, it's also about illuminating your mind and getting some exposition over these things in the process. And last but not least, another very major pivotal trend that I'm seeing in electrical engineering nowadays is cybersecurity. So with the increasing digitalization of electrical systems, it's fair to say that cybersecurity has become a crucial area of focus in electrical engineering. Engineers are working on developing secure systems and technologies to protect the power grid and other electrical systems from cyber threats. Cybersecurity is particularly important in the context of smart grids, which rely on digital technology to manage the power supply. Engineers are developing secure communication protocols as well as encryption methods to protect data that is being transmitted across the smart grid. They're also designing systems to detect as well as respond to cyber threats, hence helping to play their part in ensuring the reliability as well as the integrity of the power supply. Moreover, my dear students, cybersecurity is also a key concern in the development of IoT devices and systems in electrical engineering. So engineers are now working proactively on securing these devices and systems to protect them from cyber attacks and ensure the privacy of the data they collect as well as transmit. So to sum up, to conclude, the field of electrical engineering is undergoing significant changes that are driven by advancements in renewable energy technologies, smart grids, electric vehicles, AI, IoT, as well as cybersecurity. These trends are not only transforming the industry, but also shaping the future of our energy landscape. So, as we continue to innovate and push the boundaries of what's possible, the role of electrical engineers will be now more important than ever. So that's it for now, fellas. We'll be back in the final episode to talk about whether a degree in this field is ultimately worth it or not. Do a bit of gauging of statistics, see what the numbers game points to, right? In which direction it points to. So please stay tuned. Kindly do not hesitate to like, share, and subscribe. And once again, I give this speech every single time. Feel free to reach out in the comment section in case you got any queries. Ultimately, I mean, I'm doing this for you. So let me know whatever assistance you need, and it would be my pleasure to provide it. Thank you very much and stay blessed. God be with you all. Assalamu alaikum.